For weeks now, a persistent ridge has kept much of the Gulf Coast and southern plains locked into a dry, oppressive heat pattern. That's starting to change. Forecasters are now watching a plume of deep tropical moisture building in the Bay of Campeche. And as that moisture gets pulled northward in the coming days, it's set to genuinely shift the character of this pattern, away from dry, rainless heat and toward increased shower and thunderstorm activity across parts of the Gulf Coast. So today I want to walk you through exactly what's changing, why the Bay of Campeche specifically matters as a moisture source this time of year, and what this means for the heat pattern I've been tracking all summer. Make sure you're subscribed before we get into it, because this transition is happening over just the next several days. It's worth being precise about what tropical turn means here, since it's easy to hear that phrase and assume a named storm is involved. It isn't, at least not yet. What's changing is the source and character of the moisture feeding this region's weather, not the arrival of an organized tropical cyclone. That distinction matters for setting the right expectations for what the coming days actually look like on the ground. And it's worth keeping in mind through everything that follows. To understand why the shift matters, it helps to remember what's been driving conditions up to this point. For much of the back half of July, a ridge of high pressure has held over Texas and the northern Gulf, suppressing rain chances and allowing sinking, compressing air to build heat at the surface. The same basic mechanism behind every heat dome I've covered this summer. That ridge has been persistent enough to keep the region locked in a dry pattern even as heat index values climbed into genuinely dangerous territory on the humidity that was already present. It's worth remembering just how many distinct rounds this same broad pattern has already produced. Late June brought a heat dome to the eastern U.S. and eastern Canada, tied to more than 40 confirmed deaths. A second heat dome built over the western and north central states through the first half of July, setting all-time records in Billings, Montana. From there, the pattern shifted to the Gulf Coast and southern plains specifically, and then expanded further to include the Southwest as the Climate Prediction Center's outlook kept getting updated through the back half of the month. Each of those rounds shared the same underlying ridge-driven mechanism, just relocated to a different part of the map. This week's shift is genuinely different in kind rather than just another relocation. It's not the ridge moving to a new region, it's the character of the pattern underneath a ridge that stayed largely in place actually changing. As of the most recent basin-wide tropical update, the Atlantic as a whole has stayed quiet. No tropical development expected in the Gulf, Caribbean, or wider Atlantic through the end of July, continuing a trend that's held for most of the month given the wind shear and Saharan dust that have suppressed organized development all summer. But no tropical development and no tropical moisture are two different things, and that's exactly where this week's update becomes relevant. Forecasters have specifically flagged an area of deeper tropical moisture building in the Bay of Campeche, the southern portion of the Gulf of Mexico, tucked along the coast of eastern Mexico, as a factor set to influence weather across the Gulf Coast in the coming days. This isn't a tropical storm or an organized system in the way Invest 91L was earlier this month. It's a moisture plume, a deep, humid air mass that can get drawn northward by the broader steering pattern, even without ever organizing into anything with a name. That distinction matters practically. A named tropical system moves with a defined track and a forecast cone. A moisture plume like this one behaves differently. It doesn't move as a single, trackable center, but it can still dramatically increase available atmospheric moisture across whatever region it gets pulled into, fueling a jump in shower and thunderstorm coverage well beyond what the same air mass would produce without that tropical moisture source feeding into it. It's worth understanding why forecasters watch this specific body of water so closely during summer. The Bay of Campeche sits at the southern end of the Gulf of Mexico, and by late July, it's reliably one of the warmest, most moisture-rich stretches of water anywhere in the region. Warm enough that it's also the area where Central American gyres, broad, sprawling low-pressure systems that can seed tropical development, frequently take shape later in the season. Even without an organized gyre or invest forming, the sheer volume of deep, tropical origin moisture sitting over that warm water makes it a reliable moisture source whenever the broader wind pattern sets up to draw it northward. That's exactly the setup developing now. When a plume of Bay of Campeche moisture gets pulled north, typically along the periphery of whatever ridge has been dominating the pattern, since ridges steer moisture around their edges rather than blocking it entirely, it can inject enough humidity into the Gulf Coast and southern plains to meaningfully increase shower and thunderstorm coverage, even in a region that's been under a dry heat dome for weeks. That's the mechanical heart of this tropical turn. The same ridge that's been suppressing rain is now old enough, or positioned in a way, that it's allowing tropical moisture to wrap around its edge rather than keeping the whole region uniformly dry. It helps to picture how a ridge actually interacts with moisture transport, since wrapping around the edge can sound abstract without the underlying mechanism. High-pressure ridges rotate air clockwise around their center in the northern hemisphere, meaning the flow along the western and southern periphery of a Gulf-based ridge tends to move from south to north. When a deep, moist air mass like the one building in the Bay of Campeche sits along that southern flank, the ridge's own circulation can effectively catch that moisture and funnel it northward into Texas and the broader Gulf Coast, rather than the ridge simply blocking all moisture transport uniformly. That's different from what happens directly underneath the core of a ridge, where sinking air actively suppresses cloud development. Moisture riding along the ridge's periphery can still build into real thunderstorm activity, even while the ridge's center continues producing dry, sinking air. This is a big part of why a dry heat dome pattern rarely stays perfectly dry in every corner of the region it affects. It's more accurate to think of it as a dry core with a moisture-fed edge that can shift and expand as the ridge's exact position and strength evolve day to day. Here's where this connects directly to everything I've covered about this summer's heat. An increase in shower and thunderstorm activity doesn't necessarily mean the heat breaks entirely. In fact, tropical moisture arriving underneath a still present ridge can initially make heat index values worse before it makes temperatures better, since added humidity raises the heat index even on days where the actual air temperature holds steady or even dips slightly under increased cloud cover. That's worth knowing if you're in the affected region. A tropical turn in the pattern is not automatically relief from dangerous heat. It can just as easily mean a shift from dry, high-temperature heat risk to humid, high heat index heat risk, with the added complication of scattered flooding downpours layered on top. It's worth explaining why added humidity works against your body's cooling specifically, since it's the mechanism behind why a less hot but more humid day can sometimes feel just as dangerous as, or worse than, a hotter, drier one. Your body's primary defense against overheating is sweat evaporating off your skin, a process that pulls heat away as the liquid converts to vapor. That process depends on the surrounding air having room to absorb more moisture. When humidity is already high, the air is closer to saturated and sweat evaporates more slowly, which throttles your body's main cooling mechanism right when the added heat index would suggest you need it most. That's the entire reason a 95-degree day with heavy tropical humidity can produce a heat index of 105 or higher, even though a 100-degree day in drier air might genuinely feel more tolerable by comparison. As Bay of Campeche moisture works its way into the Gulf Coast pattern, this is exactly the dynamic worth watching for. A forecast that shows temperatures holding steady or even dropping slightly could still represent a more dangerous heat stress environment than the days that preceded it purely because of the added moisture. Where this pattern shift does tend to bring genuine relief is in the effect increased cloud cover and rainfall have on daytime highs specifically. Thunderstorm activity blocks direct sunlight and can drop temperatures several degrees during and after a passing storm, and it interrupts the day-after-day compounding heat buildup that a persistent dry ridge produces. So the realistic expectation for the Gulf Coast and southern plains, as this moisture plume arrives, is less the heat wave ends and more the character of the heat risk changes, from a dry, relentless, day-after-day dome to a more variable pattern with scattered heavy rain, localized flooding potential, and still elevated but less uniformly brutal heat. It's worth putting this into the context of where the rest of the tropics stand, since the Atlantic's continued quiet is only half the story this week. Over in the eastern Pacific, activity has been considerably livelier. Genevieve has become the first major hurricane of the 2026 Eastern Pacific season, and while it's not expected to make direct landfall anywhere, it's generating large swells along Southern California beaches this week. Well, worth knowing if you're anywhere near those beaches, given the elevated rip current risk that kind of distant swell reliably produces, even with the storm itself staying well offshore. That's worth understanding mechanically, since it's the same phenomenon I described earlier this summer with Fausto's own swell reaching California. A powerful, well-organized hurricane generates long-period ocean swells that radiate outward far beyond the storm's own wind field. And those swells can travel thousands of miles and arrive at a distant coastline as elevated surf and dangerous rip currents days before, or even without, any direct storm impact ever materializing. Genevieve reaching major hurricane status specifically means it has the sustained organization and strength to generate a genuinely strong, far-reaching swell, which is exactly why Southern California beaches are being flagged this week, despite the storm itself posing no direct landfall threat to the mainland. Hurricane Fausto, which I covered extensively as it rapidly intensified earlier this month, is now on a steady weakening trend as it continues toward Hawaii, but it could still bring periods of rain and gusty winds to the islands around the middle of next week, even in its weakened state. That's consistent with what I said when I first covered Fausto's track toward Hawaii, that the storm was expected to lose strength crossing into the cooler, drier Central Pacific, but that a general impact on the islands, even from a weakened system, remained a real possibility worth watching rather than dismissing once the storm's peak intensity had passed. A storm doesn't need to still be at hurricane strength to bring meaningful rain and wind impacts to a location in its path. The broader circulation and moisture field around a weakening system can still produce genuinely disruptive weather well after the storm itself has dropped below hurricane criteria. Between Genevieve's swell reaching California, Fausto's continued approach toward Hawaii, and now this bay of Campeche moisture reaching the Gulf Coast, it's a genuinely busy week for tropical adjacent weather impacts across 3 separate parts of the country, even though not one of those 3 stories involves an actual landfalling hurricane on the U.S. mainland. That's a useful illustration of just how far a storm's influence can extend well beyond wherever its actual center happens to be tracking. I think this is a useful moment to reinforce something I've said throughout this hurricane season. No tropical development expected is a specific, narrow claim about organized cyclone formation, not a blanket statement that nothing relevant is happening in a given basin. This week is a clean example of exactly that distinction. The Atlantic has no named storms, no invests, and no formation expected over the next 7 days, genuinely quiet by the standard measure. And yet there's a real forecaster-flagged moisture plume about to meaningfully change weather conditions across a multi-state region. Both of those things are true simultaneously, and it's exactly why I keep emphasizing that the development percentage isn't always the number that matters most for your day-to-day weather. This is worth remembering anytime you see a tropics are quiet headline over the rest of hurricane season. A development percentage measures the odds of a specific, organized, rotating system with a defined center forming and earning a name. It says nothing directly about how much moisture is moving through a region, how much rain a specific corridor might see in the coming week, or how a stalled front might interact with tropical origin humidity to produce a genuinely active severe weather or flooding setup, all without a single named storm ever being involved. Treating quiet tropics as synonymous with quiet weather is exactly the kind of oversimplification that can leave people unprepared for a real flooding event, simply because nothing on the official tropical outlook carried a name or percentage attached to it. For the Gulf Coast and Southern Plains specifically, the practical expectation over the coming days is increased shower and thunderstorm coverage compared to the drier stretch that preceded it, with a real risk of locally heavy rainfall and possible flooding in spots where storms train repeatedly over the same area. The same dynamic I've described with other tropical moisture-fed rain events this summer, where a slow-moving or repeatedly triggered storm cell can produce far more rainfall in a short window than the same storm moving through quickly would. It's worth explaining that training mechanism a bit further, since it's the specific reason a tropical moisture-fed pattern like this one can produce disproportionate flooding compared to a typical summer thunderstorm day. When deep tropical moisture is available, individual thunderstorm cells can regenerate repeatedly along the same corridor, often anchored by a stalled frontal boundary or a persistent area of converging low-level winds. Rather than a single storm passing through a given town and moving on, cell after cell can follow nearly the same track over several hours, each one dumping additional rainfall onto ground that's already saturated from the previous cell. That's fundamentally different from how flooding risk works during a dry heat dome, where the concern is almost entirely about temperature and lack of rain rather than too much of it arriving too fast. Areas that have gone weeks without significant rainfall are particularly vulnerable to this kind of setup too, since parched, compacted soil doesn't absorb water as efficiently as soil that's had semi-regular rain to keep it permeable, meaning a region coming out of a dry heat dome can actually see worse initial flash flooding from the first heavy rain event than a region that's had more consistent rainfall all along. Heat index values may not drop meaningfully at first, and could even climb further in spots where humidity increases before any real cloud cover or rain arrives to offset it. If you're in this region, that means treating the next several days as a shift in character rather than a clean break from the heat. Keep the same heat safety habits in place: hydration, limiting peak afternoon outdoor exertion, checking on vulnerable neighbors, while also paying attention to flash flood potential in a way that hasn't been as relevant during the drier stretch of this pattern. Know your evacuation routes if you're in a flood-prone area, and remember the standard rule that bears repeating every flood season. Never drive through a flooded roadway, since it takes surprisingly little moving water to float a vehicle, and floodwater frequently hides washed-out pavement underneath it. If you're along the Southern California coast, keep an eye on rip current advisories tied to Genevieve's swell, even though the storm itself poses no direct landfall threat. And if you're in Hawaii, it's worth tracking Fausto's approach through the middle of next week, even in its weakened state, given the rain and gusty wind still expected as it nears the islands. I'll keep tracking how much of this bay of Campeche moisture actually gets drawn into the Gulf Coast pattern, and whether it meaningfully dents the ridge that's dominated this stretch of summer, or simply adds humidity and rain risk on top of still present heat. I'll also keep an eye on whether the Atlantic's quiet stretch holds through the start of August, or whether increasing moisture in the basin generally starts to nudge those development odds back up as we move into what's typically a more active stretch of hurricane season. It's worth noting why early August specifically deserves that kind of attention, climatologically speaking. The Atlantic hurricane season's activity isn't spread evenly across its official June through November window. It ramps up considerably starting in August and peaks around September 10th, historically, as ocean temperatures across the basin reach their warmest point of the year, and wind shear from the higher latitude jet stream typically relaxes compared to earlier in the summer. A quiet stretch through most of July, even one this persistent, doesn't tell you much about how August and September will play out, since those later months operate under a genuinely more favorable set of baseline conditions for tropical development almost every year, independent of whatever's suppressed activity earlier in the season. That's part of why forecasters don't treat a quiet July as evidence the whole season will stay quiet. It's simply too early in the most active part of the climatological window to draw that conclusion. For now, though, the story is really about moisture and rainfall rather than organized tropical systems, and that's exactly the kind of pattern shift worth tracking closely, even without a name attached to it. As it says in Psalm 107, "He stilled the storm to a whisper. The waves of the sea were hushed." Whether it's a dry heat dome or a shift toward tropical moisture and flash flood risk, the pattern is always changing, and staying informed about which specific hazard is dominant on a given day is what actually keeps you safe, more than any single label like heat wave or quiet tropics ever fully captures on its own. Stay weather aware, and I'll keep you updated as this develops. Make sure you're subscribed so you don't miss it, and I'll see you in the next one. Stay safe out there.